This is 3-2B, and this is solving systems. So what methods have we done? Solving systems with, what was the first one? Graphing. Second one was the other one, substitution, right? This is solving systems by using elimination. Personally, this is my favorite one. You may disagree, but I like this one the best. So elimination, okay? Kara, put your phone away. Here's what you're gonna do. Your steps to solving with elimination, step 1 is you wanna start with both equations in standard form. Okay, so that's step 1. Step 2 is then you're gonna make one of your variables the opposite. So make one variable the opposite of the corresponding variable. In the other equation. Okay, so you're gonna make it the opposite. And then step 3 is to eliminate that variable. So we're trying to get rid of one of our variables. Eliminate that variable and solve for x and y, or whatever your coordinates are, okay? You'll end up, again, with a point x, y. Okay, so those are your 3 steps. If you follow those 3 steps, you will be in very good shape for the setup of this, okay? All right, so here's what we're gonna do. Example number 1. These are gonna get progressively harder, so don't pay attention to the first 2 and be like, oh yeah, I got it. Because the ones that come after that are harder than these ones, okay? There's more work to be done, so just stick with me for all of them. Here's your first system. You will have 4x plus 2y equals 9, and negative 4x plus 3y equals 16. Okay, that's our system. We're trying to eliminate a variable. So the first thing it said is start with both in standard form. Are they both in, I missed my M, sorry. Are they both in standard form right now? Yeah, okay, so we're good there. Step 2, make one variable the opposite of the corresponding one in the other equation. Do you have opposites for any of your variables right now? Yes. Yeah, you have a 4x and a negative 4x, right? So that's done for you too. So all you have to do in this problem is eliminate the variable and solve for your x and y. So I always do this, okay? If I want to get rid of x, I need to add my 2 equations together because 4x plus a negative 4x is 0, right? So think of it like this. This is one big addition problem. We're going to add 4x plus a negative 4x, which is 0. You don't need to write the 0 in, okay? Then we're going to do 2y plus 3y. What is 2y plus 3y? 5y. Bring down your equal sign. What is 9 plus 16? 25, okay? Notice our x went away. We eliminated it, okay? I'm not going to cross it out because I'm going to go back and use it, but you're going to solve now for y by dividing. So y is 5. How do we find x? Plug it in. I would use the first one just because it's smaller numbers. So I'm going to use 4x plus 2 times y, which we know is 5, equals 9. So 4x plus 10 equals 9. Okay, we're going to take away the 10. So 4x equals a negative 1. And then we're going to divide by 4 to get x by itself. So x is a negative 1/4, which means our answer is this, negative 1/4, 5. Any questions on that?
So that second equation you wrote in green is on something, it wasn't given to us, it was just...
This one was given to you as 4x plus 2y equals 9. That was this equation up here, right?
You just gave us the one equation, though, right?
I gave you 2 equations to start. This is number 1 and number 2. I gave you both of those. Is that what you're asking me?
Yeah.
Yeah, so we started with those 2. We eliminated our x, which gave us all of this to solve for y. And then I plugged that y back in to that equation. You could plug it back into either one. Okay? Okay, next one. 4x minus 2y equals 7. And x plus 2y equals 3. Okay, are they both in standard form? Yes. Do you have one variable that's the opposite of another?
Yes.
The y's, right? So your job is just to add the 2 equations together. So 4x plus x is what? 5x. Negative 2x plus, or negative 2y plus 2y is 0. You don't need to put the 0 in. It doesn't change anything. So just bring down your equal sign. 7 plus 3 is 10. So if 5x equals 10, then x is 2. Okay, so we have our x. Then you go back and plug it in. I would plug it in right here, but you may do it in the top one. Okay, so if we plug it in, it's 2 plus 2y equals 3. I just plugged it into that. Now you solve for y. So take away the 2. You're left with 2y equals 1. So divide by 2. So y is 1/2. Which means our answer, our solution here, is 2 1/2. All right, my x value and my y value. Put your phone away. That's not away. Questions on that? All right, take it up a notch. That was B. I don't think I wrote B. This is C. Here is your system. You have negative 2x plus 5y equals negative 2. And you have x minus 3y equals 3. Okay, are they both in standard form? Yes. Do you have opposite variables? No. Okay, your job is to make them opposite. So which equation do you think we're going to change? The second one. The first one, you have a negative 2, so it would be helpful if you got a positive 2. So what do I need to multiply this whole equation by to get a positive 2 for x? Multiply it by 2. Okay, so now that equation is going to become 2x, right, minus 6y. Don't forget to do the last one. That one gets forgotten a lot. Equals 6. Okay, so now you are completely ignoring this equation for now. Your new system, you don't need to rewrite it, but if it helps you to see it, rewrite it. Okay, I'm going to rewrite it just to show you, just to keep it clear. So we had negative 2x plus 5y equals negative 2, and now we have this one with it. Your job then, if they're opposites, is to add the 2 equations together. So 2x plus a negative 2x goes away. Negative 6y plus 5y is what? What? Negative 1. So it's a negative 1y. 6 plus a negative 2 is 4. So divide by -1, and your y value is -4. Okay, now you're gonna go back and plug that in. Now, just be careful. If you plug it into this one, that's great, but don't do anything with that 2, okay? You may plug it into this one, you may plug it into this one, or you may plug it into that one. Now you have 3 equations, essentially. I would plug it into the x minus 3y, so x minus 3 times your y values in -4 equals 3. So that's x plus 12 equals 3. So take away the 12, and x equals -9. So your answer is -9, -4. Questions on that? Okay, then we're going to take it up another notch. This is D. There we go. So for this system, we have 2x plus 7y equals 4, and 3x plus 5y equals -5. I didn't change colors, sorry. Okay, this is pretty much as hard as they get, where you have to do what we're gonna do right here. Are they in standard form? Yes. Do you have opposites? No. Can you multiply one equation to get opposites? Not nicely, okay? You could, but you would have to multiply by a really weird number. So instead, you have to multiply both of your equations, and we want them to be opposites. So there's a lot of options here. Typically, if you just take the coefficient and swap them, but make sure one is negative if you need to make them opposite, right? So I would take this whole thing and multiply by 3, because that's this number. And then I would take this whole thing and multiply by what? Not 2, -2, because we want them to be opposites of each other, right? So multiply it by -2. So what you're gonna get here, I'm gonna start with this top one. 3 times 2x is 6x. 3 times 7y is 21y. And then 3 times 4. Make sure you multiply by the constant, okay? It always gets forgotten. I don't know why, but it just does. I think the equal sign throws people off. Multiply by all 3 of them. That's 12, okay? Now do the purple to the green. -2 times 3 is a -6x. -2 times 5y is a -10y. -2 times -5, oops, is a +10. Let me just erase that so I'm not confusing you. Okay, so that's your setup. What do I do with them? You add them, right? We're gonna add the 2 equations together, and that will cancel out our x's. So what's 21 plus a -10? 11, +11. Did I miss a sign? No, I think we're good, yeah? Okay, so that's 11y. 12 plus 10 is 22. So divide by 11, and you get y equals 2, okay? Then go back and plug that y in. You have 4 options. You can plug it in here, you can plug it in here, you can plug it in here, or you can plug it in there. I usually just pick the one that has low numbers. Allure.
We have to have 2 answers each time.
An x and a y, yes. So I'm gonna plug it into that top one. So 2x plus 7 times your y value, which is 2, should equal 4, okay? So take away, this is 14. Take away 14, you get 2x equals -10, and then divide by 2. So x should be -5, okay? That means our answer is -5, 2. Make sure that x is always the first letter, right? It's a point. So X, Y. Questions on that? No, it's not. Okay, I'm gonna go back and do one more of those if we have time, but I wanna make sure I get to these special cases. There are a few scenarios where it doesn't work out to a point. So these are the special cases. Okay, here's what they look like. Let's say our system is negative 3x plus y equals negative 5. And then 3x minus y equals positive 5, okay? Do you have opposites right now? Got a whole lot of opposites, right? Okay, so let's just add these two equations together. Negative 3x plus 3x is what? 0. Y plus a negative y is what? 0. So you have a 0 on your left side. Bring down your equal sign. Negative 5 plus 5 is 0. Your variables disappeared. Okay, when you lose your variables like that, what's your answer? This is infinitely many, right? Or an infinite number of solutions. So exciting. Okay, so this is infinite when they are equal to each other, because it's true always, right? 0 equals 0, 11 equals 11. It won't be 11 equals 11, but that's infinitely many, which means this would be considered dependent. If we're going back to yesterday's stuff. Okay, yeah.
Why wouldn't it just be the point 0, 0?
Because it's not saying x equals 0. It's saying 0 equals 0, right? The x's and y's went away. They canceled out. So if 0 equals 0, that's always true. So what they're saying is you could put in any number for x and y that works, and it will always be true, okay? Okay, second one. RB here. Now our system is 4x minus 6y equals 6, and negative 4x plus 6y equals 10, okay? Do you have opposites? Yes, you do, right? So we're gonna add the two equations together. 4x plus a negative 4x is 0. Negative 6y plus 6y is 0. 6 plus 10 is 16. So this is saying 0 equals 16, which it does not, right? So what is that? That's no solution. So this would actually be, this top one would be the same line, right? When there's infinite solutions, it's the same line. No solution here means you have parallel lines, which we call inconsistent. Okay. Questions on those? Those are the special cases. Okay, I have 5 minutes, so I'm gonna do one more of the change both equations. You need to be your own evaluator. If you are 100% confident that you've got this and you really wanna start on the homework, fine. If you're not 100% sure you've got this, then you need to watch this. So, be your own judge. Here it is. This is, if we're keeping going on the other one, this would be E. Okay, so your system is 3x plus 7y equals 15, and 5x plus 2y equals negative 4. Okay? We don't have opposites. We can't multiply one of them to get opposites. So we have to multiply both. What shall we multiply the top equation by? And you have options, okay? You could do your x's or you could do your y's. Okay, but if we multiply it by 2, oh, you're doing the y's. You're gonna change your y's? Okay, we'll multiply the top one by 2. So then what do we have to multiply the bottom one by? Not 7, negative 7, right? We want opposites. So my new equations will be 6x plus 14y equals 30, and negative 35x, not plus, shoot, minus, negative 35x minus 14y equals 28.
Mr. Hoover,
Yeah.
was there a specific reason why you decided to multiply by the coefficients of the y's over the x's?
Only because Allure chose it. You could do your x's just fine. So it's whatever you prefer is fine. Okay, so simplify this. We're gonna add the two together, the two equations. 6 plus a negative 35 is a negative 29x. Negative 14 plus 14, or vice versa, is 0, equals 30 plus 28 is 15. Notice how the numbers work out pretty nice all the time, right? Sometimes you get like a fraction. That's okay. You'll never get 2.9738426. So if you get something like that, you're wrong, okay? Try again. Okay, so this one, divide by negative 29, and you get x equals negative 2. And then plug in that 2, and again, you can plug it in here, you can plug it in here, you can plug it in here, or you can plug it in here. I would not choose the bottom two just because they're bigger numbers. You don't need bigger numbers. Just pick one of the first two. So I'm going to do that first one. So it's going to be 3 times negative 2 plus 7 times y equals 15. So this is negative 6 plus 7y equals 15. So we're going to add 6. And you get 7y equals 21. And then divide by 7. So y is 3. See how they work out to such pretty numbers? So your answer would be negative 2, 3. Okay? That is elimination. Any questions? How about you, Cole? Questions on that? Oh, hi.